Hey everybody, welcome back to another SasView tutorial. I'm Brayden, and in this episode we'll be going over how to create a simple model in SasView using the built-in model editor. I'll also go over how to read and interpret the model documentation. Before we begin, it's important to understand that there's no difference between the model that we're going to create today and a built-in model in SasView. Additionally, there's no limit to the complexity of a model you can create. For today though, we're going to stick with replicating the built-in sphere model in SasView. Now that you have SasView open, the first step is to open the model editor. This can be found under Fitting, Add Custom Model. In this new model editor, you can see that we can specify the name for our model, the description for our model, our parameters, and the scattering equation. Starting at the top, let's first input a name for our model. Because we're copying a sphere, I'll call it my sphere. Next, we need to input the description. The description is an important part of the model because it will tell you and others what the model is supposed to be about. This can be as long and as detailed as you like, and it will be pulled into the documentation for your model if it gets generated. In our case, let's call it my copy of the sphere model. Now for our parameters and scattering equation. At this step, it's important to recognize that you have to have a scattering equation in order to make a model. This can come from your work or from an external source, but in our case, we're going to be using the sphere model, which is built into SasView. So in order to find what the scattering equation is for a sphere, we'll need to load the sphere model in SasView. So I'll move this box to the side and go to my fitting window. From here, I'll choose category, sphere, and model name, sphere. You can see that our model has been loaded because the parameters have been loaded into the fitting window. From here, we can press help, which will display the help window showing us the sphere documentation. And now you can see we have the sphere parameters here, an equation for the sphere, scattering equation for 1 dimensions, and a one-dimensional plot. What matters the most to us are the parameters and scattering equation. So I'll draw this to the side and bring back up my model editor. So now, one of the first things that we should notice about this model is that the number of variables does not match the number of parameters in the model. There's not a one-to-one correspondence. For example, scale, background, and radius are all in both. We see background here, scale here, and this R stands for radius. However, SLD and SLD solvent aren't directly in our scattering equation. That's because they've been combined into this parameter delta rho, which is SLD minus SLD solvent. Additionally, we also see that this variable V for volume is not included in the parameters that we input to the model. That's because for a sphere, volume can be determined by just the radius alone, which means we won't have to input it as a separate parameter. Okay, so now it's time to create this model in our model editor. First, we'll need to define our parameters. We have 3 parameters that we'll need to input: SLD, SLD solvent, and radius. SasView will take care of background and scale, and it will automatically add them to all models. So, first I'll create a parameter R for radius and set it equal to 1. Now I'll create a parameter SLD for scattering length density, and we'll call this one 1 for default, just like it is defined in the sphere model. Then I'll define a parameter SLD solvent, which I will define as 6, which is a default value in the model. Okay, now it's time to actually copy in the model equation. The first thing that I'm going to do is worry about this left bit of our equation here. Looking at this part of the equation, we notice that we have 3v times delta rho, and all of this will end up being squared. Outside of this parentheses, we're dividing by volume. Therefore, this v will end up being v squared, and we will eventually end up dividing by v. So one of these v's will cancel, so we'll only need to worry about one volume parameter. 3 will just get squared and become 9. And since we're not worrying about scale, this will all simplify to 9 times v. Okay, so I'll add that into my intensity equation. So I'll open a parentheses and input 9 times, and then the volume of a sphere, which, if you remember, is 4 over 3 times pi r cubed. So first 4 over 3 times pi and of course radius, which we define as a variable, cubed. I'll move this over so we can see the rest of the model editor better. So this next part of the equation is all going to end up being squared, so I'll open up another parentheses. Inside this parentheses, we need to define delta rho, which is the difference between our two SLD terms. So I'll put an SLD minus SLD solvent, close parentheses, and now we need to multiply that by the Bessel equation, which is essentially the rest of the equation. I'll open a parentheses, and we'll start by typing in sine of Q times R. This will be subtracted by Q times R times cosine of Q times R. And if I'll close parentheses, this will all be divided by Q times R, and that will be cubed. And I'll close parentheses. And we can't forget to square this last part of the function. Now this should be the entire scattering equation. I'll hit apply, but it seems like an error just popped up. This error is informing me that I already have a model of the same name installed on my computer. If you get the same error, all you need to do is check this box in the top right hand corner. All this tells SasView is to overwrite the existing model of the same name, so you shouldn't have any error saving. And if I hit apply again, you'll see that my sphere has been created successfully, and a new tab has appeared in the top right. If I open up this tab, we see the Python file. This Python file is what SasView will use to run all the scattering calculations it needs based on our model. First, we have a docstring. This docstring is automatically generated, and you can see that it has components of the fields that we inputted for our model. For example, we have a generated header, including the name of our model, my sphere. Now we have the description, and this will all be pulled in for our model documentation if we generate it later. Scrolling down a bit, we have a series that has a lot of flags. It's okay if you don't see these flags in your version of SasView, because they're automatically set to the default values, so we'll just ignore them for now. Next up, we have our parameters, and as you can see, we have our three parameters, radius, SLD, and SLD solvent. And looking across the variable, this is defined as the name being R for radius. We have not specified units, and the default value is 1. We see the same for SLD, and for SLD solvent, the default value is 6. The upper and lower bounds for these variables are automatically set to negative infinity and positive infinity, which you can see right here. And we have not yet specified a type or description, so these next two slots are blank. We won't worry about specifying any of these other details for now, but we will come back to it later. Below that, you can see our I of Q, or our scattering equation, and this has been copied in directly from what we typed in this box over here. Before we move on, let's double check to make sure that our model looks the same as the sphere model in SasView. I click back onto our fitting window and close the log explorer so I have more space. We can see that we've already loaded the sphere model. Let's hit calculate and then compute plot. This will show us the same graph of the sphere model that we saw in the documentation. I'll move this to the side and I'll open another fit window by going to fitting, new fit page, and I'll close the log explorer. Now if I go to plugin models, my sphere, we'll see that the parameters from our new sphere model that we just created have been loaded into the fitting window. Now it's set all the parameters the same as the parameters in the sphere model. Our radius needs to be 50, and our SLD and SLD solvent have to actually be scaled down. This is because if we look back at the documentation, the units for SLD and SLD solvent are much smaller than 1 or 6 by itself. So we need to make sure that these are the correct units. Later, we can go in to make the model work exactly like the built-in SasView model, where you would not have to do this. But for now, just to get things working, we can input 1e, -6, scientific notation, and 6e, -6. Now if I press enter, now we have our graph. And as you can see, it's the exact same shape. I'll plot it against the other one so that we can see the difference. Looking at this combined graph, however, we can see that our model, which is represented by M3, is actually about 8 orders of magnitude smaller than the actual sphere model. This once again has to do with our units. If we look at our y-axis label, we see that the units are centimeters to the negative first. Looking back at our help page, we'll notice that our equation calculates intensity in angstroms, or meters to the negative 10th. So, because centimeters are equivalent to meters to the negative second, we'll notice that those 8 orders of magnitude that we're off is simply because we're calculating scattering intensity in angstroms as opposed to centimeters. In order to fix this, we'll need to go back into our model. So I'll pull that up. Going over to the Python file and scrolling down to I of Q, let's add a new line. Here, let's redefine the intensity. And we'll make sure to multiply it by 10 to the power of 8. Using scientific notation here is okay. And I'll add a comment so that we know that this is converting from angstroms to centimeters. If I hit apply, we'll see that my model has successfully been saved. I'll close back out the log explorer. And then if I close out these graphs that we no longer need, I can type back in our SLD for 1e negative 6 and 6e negative 6. I can calculate that and plot it. Oh, and we can't forget to set our radius back to 50. And now we see that our intensity is back up at 10 to the third, which is exactly where it should be. Okay, but you may have noticed that this is a very cumbersome way of inputting our SLD values. And if we look back at the SasView sphere model, we can see that it automatically seems to know the right units, so we only have to put in 1 and 6 as opposed to 1 times 10 to the negative 6. We can replicate this in our model too. First, let's go back to the model editor. The first thing we'll need to do is to create a new line of code that will correct for this error. Intensity will equal intensity times, and this time we need to make sure that we're multiplying by 10 to the negative 6. So 1e negative 6. And this is for ease of use. So that's what I'll put in our comment. Okay, now if I hit apply and close out this log explorer, now I should be able to, after I close out our previous graph and put radius to 50, compute plot. And yes, as you can see, we still get our nice sphere plot. However, now we've overshot. What might be happening? Well, the answer is, you guessed it, in the units. If we look back at our sphere model, we need to factor in the fact that this is not just 10 to the negative 6. Because our delta rho is being squared, those values will end up being 10 to the negative 12, which is exactly why we're off by an order of magnitude of 6. So, going back to our sphere model, I can rewrite this to be 1e negative 12. Hitting apply, and repeating the same process as before, closing out our previous graph, and setting the radius equal to 50. After I plot it, we'll notice this is the exact right graph. So we've done our goal successfully. Now we need to inform the user what units these parameters are in. So we can go back to our model and scroll back up to our parameters section. Here, we can input in the units section the type of units that SasView expects us to input. First, looking at radius. Our units are angstroms, so I'll put in ang. And for SLD, our units are 10 to the negative 6 divided by angstroms to the second. And our units are the same for SLD solvent, so I'll copy and paste them. Now I'll hit apply, close this out, and we can see that our units have been loaded into SasView successfully. Now we've essentially made a copy of the sphere model, but we need to clean up the code base a little bit more. Instead of redefining intensity twice, we can combine our operations into only multiplying by 10 to the negative 4th. So I'll do that. In fact, this line, intensity equals intensity times 10 to the minus 4th, is extremely common and is found in virtually all SasView models, so make sure to include it in your own model. I'll hit apply, close out, and just to double check, well, we can add radius equals 50, hit enter, And as you can see, we've now successfully recreated the sphere model in SasView. Thanks so much for tuning in, and I'll see you next time on the next tutorial.